All right, so artificial intelligence. Now, we can do a lot of things with computers. This isn't about what you do with them. It's about why did we even create these tools in the first place 70 or 80 years ago? We created them to be able to take in data, to process that data in some way, and to send that data on. And again, I know that seems rather simplistic, but that's actually what computers do. Now, because they can work with so many different types of data, they can be very versatile tools. Because they are so rapid now, because they can do that, this process of taking in data, processing it, and sending the data on, because they can do that so quickly, the types of work we've been able to use them for have expanded over and over and over again throughout the decades. Today, we're going to talk about how to use this purpose of a computer, or how to exemplify this purpose of a computer in a field called artificial intelligence. And even though it may appear complex at first, and even though we are going to break down the concepts involved, please keep what's on the screen here in mind. Everything we're going to talk about is a matter of taking in some data, processing it, and sending the data on. All right, so what is artificial intelligence? Artificial intelligence is the action of taking a computer and using it to perform tasks that formerly were only the province of human beings. Now, there's lots of tasks that human beings can do that are very rudimentary or can be automated pretty quickly. Like, think of a recipe. When you're like in the kitchen and you're using a recipe, that's a step-by-step kind of thing, right? It doesn't involve a lot of thinking. Now, no offense at all to the cooks in the audience. In fact, my wife is a phenomenal cook, and there's absolutely an art to what they do. But especially for the non-gifted cooks like me, if I were to just step in, take a recipe, and just follow it one step at a time, and not deviate from it in any fashion at all, if it's a decent recipe, I'll have hopefully a decent product at the end of this. There are types of tasks that human beings do, though, that are not strictly linear tasks where you just do one step after the other. And they generally involve working with lots of data and thinking about the data, making conclusions, and making predictions about things. And this is the realm of artificial intelligence. Before we go one step farther, though, there's something super important I want to let you know. For many of you, this will be like obvious, but every once in a while, in fact, fairly commonly, we find that it isn't obvious. Some people are actually under the impression that computers can think, that they can actually like reason. They can't. And with the technology we have on this planet right now, I don't know if they ever will be, because they're not actually alive. The thing is that as we evolve this area of artificial intelligence, some of this action of putting data into a computer, processing it, and getting data out of it, it starts to look like, in that processing the data thing, that the computer actually thought, that the computer applied reason. It can really start to look like that in terms of your interaction with the computer. I assure you, the computer is not thinking, even though it looks like it is. They're just doing what's programmed into them. It's just that the things we've been able to program them to do look remarkably like thought was involved. All right, so we're going to look at some of the components of artificial intelligence. It's a broad field, and it includes a lot of things, right? One of the things I want to talk about is what's called natural language processing, also called NLP. Natural language processing means taking a computer program, an artificial intelligence program, which is a complex program designed to work with data, and feeding it text data. And more precisely, text data that shows human communication. Think novels and books and web pages and reports and all the text that represents people communicating. And there's a subdivision of artificial intelligence that works with that kind of data. And in particular, it's really good at taking a huge set of data and then giving you two functions. One, you can tell it to create information that seems logical, written communication that seems logical, based on a subject you want to ask it about. And two, you can use it to survey or ask questions of a giant body of written data. So think of it like the web, except instead of being a huge collection of web pages, it's a giant collection of natural language, written data that you can ask questions of. The next area of artificial intelligence I want to talk about is what's called computer vision. Computer vision is utilizing computers to be able to interface with the real world through images, through cameras, and to be able to analyze those images and make predictions or demonstrate an understanding of what's in the image. Think of facial recognition in this area. This is a pretty good example of what computer vision might be. Then there's machine learning. Machine learning is creating specialized artificial intelligence programs that can take in tremendous amounts of data, analyze processes, and start to predict what would come next. So if you have a tremendous amount of time data, like historical records of weather or of cultural aspects like entertainment or energy consumption or these kinds of things, machine learning can pull in all that data, crunch a bunch of numbers, and start to predict what might occur in the future, which is kind of cool. Another area of artificial intelligence is robotics, which is the physical universe to software interface, and being able to have devices that can sense the outside world. Remember, this is why I said to bear in mind the purpose of a computer. The purpose of a computer is to take in data, process it, and send the data on. What's really cool about robotics is the data that can be pulled into the computer is real world physical universe data, the dimensions of an object, external environmental factors like temperature and pressure and humidity. All these things can be fed as data into the computer. They can be processed, and the data that comes out can be commands to control a physical device like a robot. Examples might be devices that can work in a warehouse, read a barcode on a box that contains some sort of a product, and also scan the dimensions of that box. And if it's the right box, open up an arm, grab the box, and then transport it somewhere. This is robotics. There's another term I want to cover, which is cognitive. Cognitive means of or related to thought. So cognitive computing is the attempt to create computer programs that emulate the workings of the human mind. All of the various millions and billions of connections that there might be between data that is either data that are similar to each other, different from each other, or identical to each other, and to take all that data and use it to quote unquote think. Again, real thinking isn't occurring, but the product of a huge computer program like this that emulates the way the brain works can appear to be like thought, form conclusions based on a tremendous amount of data.